Analysis of multiple choice question exam quality by performing item distractor analysis in SPSS using two different methods. The first one is the distractor percentage, calculated by counting the number of students selected the distractor divided by the total number of students multiplied by 100. And the other method is the Kelly's equation method for item discrimination, which is equal to the upper group minus lower group divided by the 27% total. Analysis of multiple choice question exam quality by performing item distractor analysis in SPSS. A distractor is the wrong answer in a multiple choice question. If a multiple choice question has 4 answer options, one of the answer option will be the correct answer, and the other 3 answer options will be the wrong answers, and they will be the distractors. And the function of the distractor is to distract the student or students from selecting the correct answer and attract them to select the wrong answer. So a distractor will be considered functional or effective if it is attracting more than 5% of the student for selecting that distractor. And if the distractor has a percentage of students selecting the distractor of less than 5, then the distractor is not functional or not effective. So a distractor aims and objective from analyzing the distractor is to find out and evaluate the efficiency of the distractor in distracting the student from selecting the correct answer. And the way to calculate and evaluate the distractor effectiveness is to use the formula below by calculating and counting the percentage of the distractor through counting the number of the students selecting distractor 1 or 2 or 3 divided by the total number of students multiplied by 100. In this data view in SPSS, I have a data extracted from a exam result for 25 students answering 15 multiple choice questions with 4 possible answer options labeled as A, B, C, D. And for each multiple choice question, there is one correct answer. In the case of question number 1, the option P is the correct answer. For question number 2, the P is the correct answer. And for question number 9, the correct answer is C. And for 15, the correct number is D. And to evaluate the effectiveness of the distractor, which are the wrong answer, such as in the example of question number 1, A and C and D answer options are the wrong options, so they are the distractors. And to evaluate the effectiveness of these distractor to distract the student or the students from selecting the correct answer, we're going to use the formula described previously. And the way to do that is to click on transform, click on compute variable, and in the compute variable generate a target variable, call it option A, and then we're going to select A, move it to the numeric expression. We're going to divide that by 25, which is the total number of students, then multiply that by 100 to get the percentage. And if you click on OK, a new column is generated, or a new variable is generated labeled as option A. And I'm just going to do a few editing here, reducing the decimal to 0 and this column width to 5, and the align the value into the center. And I'm going to also generate and compute the percentage for option B and C and D, and by clicking on transform, compute variable, reset this, and then call it option P, and then select the data or the variable P. Going to divide that by 25, multiply that by 100, click on OK. Again, a column here is produced, and I'm going, or a variable, a new variable, we're going to do the editing and then make it center. And I'm going to do the same thing for option C, reset option C, and then select the variable C, divide that by 25, multiply that by 100, click on OK, a new target variable is generated. I'm going to do some editing here, reduce that to 5, and that's into the alignment, make it into center. And then I'm going to also compute variable for the last answer option, which is D, and I'm going to erase this and then select D, divide that by 25, multiply that by 100, click on OK, and a new target variable is generated. Doing some editing here, reducing the decimal, reducing the column width, and making the value centered. And here I have the percentage of each answer option in each question selected by the student. And if we look at the data here, we can see that from question number 4, the option A percentage is 4, and that is less than 5. So this distractor is not distracting the student from selecting the correct answer, as there are less and less students selecting this wrong option. So for question number 4, answer option A need to be replaced or changed, as it is non-functional or ineffective. Question number 5, option D have a percentage of 0, which means that no student has selected that answer or this option. Again, this is a non-functional distractor, as it failed to distract the student from selecting the correct answer and did not attract the student to select it. So this is an ineffective distractor, need to be replaced or rephrased. And if we scroll down a little bit to question number 10, we can see here that distractor A and distractor C, the value is below than 5%, which means that this distractor failed to attract students, and their value is less than 5, which means that they are non-functional or ineffective and they need to be replaced. And again, the same for question number 9, option A, question number 8, option A, and also for question number 13, as it have as option C 0 value. Question number 12 have two option C and D, a value less than 5, and question number 15 have option C less than 5. Percentage of the student selected that options. This is the way to evaluate and assess the distractor effectiveness and to determine whether the distractor is functional and effective or not functional or ineffective and this is the way to do it in SPSS. Analysis of multiple choice question exam quality by performing item distractor analysis in SPSS. A distractor in a multiple choice question is the incorrect or wrong answer option. A multiple choice question that have 4 possible answer options will have one of the answer option as a correct answer and the rest will be incorrect answer options, and those are called distractors. The function of the distractor is to distract the student from selecting the correct answers and attracting them to select the incorrect answers options or answer options. A distractor can be functional and effective if it is attracting low performing student to select the wrong answer, and it will be non-functional or ineffective if it attracts high performing student to select those wrong answers, or if the distractor doesn't distinguish between high performing and low performing students, and thus both high performing and low performing students are selecting the distractor at an equal proportion. And the way to analyze the distractor is to use the Kelly's equation method for item discrimination as given below here, that is equal to upper group minus lower group divided by 27% total. For calculating the ID, first the total score achieved by each individual student participating in the exam will be calculated, and then this total score is arranged from high to low, and then two groups are generated, the upper group and the lower group. The upper group represent the top 27% of the total scores, and the lower group represent the lowest 27% of the total score. An item discrimination will generate a value ranging from -1 to 1. A distractor that have a value of close to -1 will indicate that the distractor is functional and is effective, as it is attracting more low performing student than high performing student. A distractor with a value of an ID equal to 0 indicates that the distractor is non-functional and it is ineffective, and the distractor ought to be replaced or rephrased. If the distractor value of an ID have a value of greater than 0 up to 1, then the distractor again is ineffective, as the Distractor is attracting more of a high performing student to select this wrong answer. Here in SPSS data view, I had placed a data extracted from an exam paper answered by 25 students that were answering 15 multiple choice questions from question number 1 to question number 15, and each question has 4 possible answer options labeled as A, B, C, D, and the correct answer for questions are given a value of 1. For question number 1, the correct answer option is B, and the student that selected the option B is scored as a value of 1. The other answer options such as A and C and D are the wrong answers or answer options. Thus they are the distractors that distract the student from selecting the correct answer. And the value for this distractor is given a score of 0. If a student select any of the distractor, then it is given a 0 value. Student number 2 here for question number 1 has selected option D, and student number 4 selected distractor A, and student number 6 selected distractor C. And to evaluate the quality of the multiple choice question exam is to do an item distractor analysis using Kelly's methods. And the way to do that is first to calculate the total score achieved by the participant in the exam. And the way to do that is to click on transform and then select the count values within cases, and I'm going to generate a target variable calling it total score, and I'm going to use the variable here, select them all except the student 1, transfer them to the numeric variable, and then in numeric variable, and then in the define values I'm going to select the value of 1 and transfer that into the box value to count by pressing the add and then click on continue. The software here will count all the correct answer by counting all the value that have 1 for each individual student. And if we click on OK, a new variable is generated to the right hand side as shown here, and I'm going to click on a variable view, and I'm going to do view editing here by decreasing the decimal to 0 and decreasing the column width to 4 and place the value in the center. Again, as we can see here from the total score, that the highest score achieved is 14 out of 15. So 14 questions were correct out of 15, and the lowest score is given here 5. For each individual student, the total score is counted and calculated. The next step in the Kelly's method is to rank these total scores in a descending order from high to low. And the way to do that is to click on data and then scroll to sort cases, and then in the sort cases we are going to use the total score for sorting the data in a descending order. So in the sort order, going to use the descending. If I click on OK, the software will rearrange the data so that the highest score is organized from top to the bottom. So the highest is 14 and the lowest is 5. So now the total score has been ranked. The next step is to transpose these data. And to do transpose, click on data, scroll down to transpose, click on transpose. In the name variable, select student, and in the variable select by all the variable by clicking on Control A, and then click on the arrow. All the variable move to this box. If I click on OK, the software will rearrange the data that the students now are on the top here, and the questions are in rows or cases. And I'm going here to do a few editings for all this data, transposed data. The first thing, and I'm going to rename the student number and replacing the K by S. The way to do that is to click on Control F for find and replace, and click on replace, and then type K and then the symbol, and then in the replace I'm going to put a capital S for student, and I'm going to click on replace all. So all the cases are renamed as S1 to S25. The next thing to do is I'm going to decrease the decimals into 0. So select, copy, and then Control V. And the column width, I'm going to reduce it into 4, make it 4 for all, and then copy, and then Control V. And for the align, I'm going to leave them all the value in the center of the cell. So I'm going to select, copy, and then Control V to make it center. So the data now are neat and tidy. And I'm going to get rid of the row for the totals as it is not required here by clicking on selecting and delete. The next step is now to generate a variable for the upper group and the lower group. Since we have here 25 students, then 27% of those are nearly equal to 7. So we are going to generate an upper group and lower group. Each group has scores for 7 students. So, and the way to do that is to click on transform, then count, and then I'm going to place here in the target variable upper group. And since these data are in order, or these variables are in order according to the total score, then for the upper group I'm going to select the top 7 variables or scores, 1, 2, 3, 4, 5, 6, 7, and drag it into the numeric variable And then in the define, I'm going to change, select a value of a range from 0 to 1 and click on add, and then click on continue, and then click on OK. So a new variable is generated for the upper group. Just to do some editing. Next is to generate the lower group. Again, click on transform, count values with or within cases, reset this and type again lower group. And since we already know these data are in order, I'm going to choose the bottom 7 variables. 1, 2, 3, 4, 5, 6, 7. Drag it and move it to the variables, and then in the define values or value, click on the range, insert a 0 and then insert 1, and then click on add, and then click on continue, and then click on OK. And again another variable is generated on the right hand side here. Going to do again few editing here, reducing the decimal to 0, the width into 4, and the data in the center. Once we have calculated the upper group, the lower group, it's time to determine the item discrimination for each individual distractor in the exam. And the way to do that is to click on transform, then click on compute variables. In the compute variable, going to generate a target variable, call it item discrimination ID, and for ID we're going to generate a numeric expression by opening a bracket, selecting now the upper group, placing a minus sign, selecting the lower group, close the bracket, divide that by 7 as we have 7 students for each group, click on OK. Again a new variable is generated. Doing a few editing here, I'm going to increase the decimal into 3 and reduce this to 4 and make it center. Now here we have the item discrimination for each individual distractor, and for question number 1, which have A, B, C, D as an answer options, we already know that option B is the correct answer, so the distractor are A, C and D. If we look at the first distractor, the value is minus. This distractor is functional and is effective as it has a minus sign, which indicates that the distractor is attracting low performing student to select the wrong answer compared to the high performing student. For distractor C, the value of the item discrimination is 0. This indicates that the distractor is non-functional, is not discriminating between high performing students and low performing students, so it is useless and it needs to be replaced or rephrased. And if we also look at another question, number 2 has a similar pattern, and I'm going to look at this value here for question number 3, option P, which is again a distractor. And as we can see here, the value for the item discrimination is in a plus, and it is 0.285. This distractor is ineffective and non-functional, as in it is positive. So it is attracting more of a high-performing student to select this distractor or select the wrong answer. So this distractor need to be replaced, changed, or rephrased. So this is the way to evaluate the multiple choice question exam and to analyze the distractor using the Kelly's equation method and to determine a value, and from that value we will assess the and identify which distractor is functional, effective, and which is not.